need to approximate the value of f prime of 5.5. So if we look at this here, we see that we have this here, graph of f is horizontal, concave down, blah, 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 linear, so forth and so forth. Now, the value of f prime of 5.5 is the slope of the tangent line at that point. So let's get an idea of what that looks like. So the slope of the tangent line looks like this, more or less, okay? I mean, that's a rough estimate. But yeah, that's the tangent line. And I want to approximate the slope of this line using these table values. Now, the key here is that you don't want to use, right, this point and this point, because this piece of the function is not in a continuous way. It jumps, and this piece isn't going to be a good approximation of this tangent line if I use this point and then this point. So basically what I want to do here is I want to use this point, the point at 5.5 for x. So let's mark out our 2 points that I want to use, this point and the point at 5. And I want to compute the slope of the secant line. And that's going to be a decent approximation of the slope of the tangent line. So the slope of the secant line joining these 2 blue points is going to be f of 5.5, right? 5.5, and I know that value. The y2 value minus the y1 value, f of 5 over the subtraction of the x values, which is 0.5, right? Or 5.5 minus 5. Let's just do that. Then I'm going to get, this is 0.5, 5.5, f of 5.5, I go down to this table, is 3.244 minus f of 5 is 3.455. Now I want to find out what this equals. Let's see what we got here. We're going to get negative 210, or negative 0.210 over 0.5. Did I do that arithmetic correct? Just make sure that my arithmetic is correct. Oh, I don't think it is. Nope, it's not. So let's see, 455. Let's take our time. This is wrong. Minus 244. 112. There we go. I was off by 1. 211 over 2.5. Now this is the same thing as this value times 2, which is 0.422. And it's negative. Sorry, I forgot. This one's negative. And this is an approximation of the value of the slope of the tangent line is the slope of the secant line joining these 2 points here. B. So now it's asking in part B, it's saying, is there an x between 0 and 6 with limit as h goes to 0 of f of x plus h minus f of x over h equal to 0. Now the key here is to notice that this part right here, this left-hand limit, or not left-hand limit, this left side of the equation over here, okay, this is the slope of the tangent line at x. This is slope of tangent line at x. Okay, this limit thing here. Okay, now if we see that this is the slope of the tangent line at x, the next thing we need to know is horizontal line has slope equal to 0. Okay, and with knowing these 2 things, the question becomes, is there a tangent line that's horizontal between 0 and 6? Is there a tangent line that's horizontal? And if you read here, the graph has a horizontal tangent line at x equals 4. horizontal tangent line. What's the slope of the horizontal tangent line? The slope is 0. So then that means that there exists an x value with this limit equal to 0. To evaluate these three limits, and we have to be careful when we're doing this. So basically, let's look. So this is saying the limit as h comes to 0, but from values above 0. So f of 6 plus h, right? That's over here, right? That's 6 plus h. And if you look, this here, right, minus this value, which is 1, okay, as I get closer and closer, it's just going to be exactly the slope of the tangent line at 6, okay, if we drew this line, which is just the slope of this line. And we could just compute the slope of this line. And that will give us this value. That's if h values are greater than 0, because then that means that 6 plus h is to the right of 6. If h is greater than 0, then 6 plus h is to the right of 6. So I'd be coming from this direction, and I would want to find the slope of this line. So it's y2, which is 0, right? This point, I'm using this point and this point, minus y1, which is 1, over x2, which is 8, over 6 minus 6 x2, because that's the 6, right? This point right here is 6 comma 1. Just make it clear. This point right here, 8 comma 0. So it's y2, 0 minus y1 over x2 minus x1. This is 2 and negative 1. So this first limit is negative 1/2. Okay, equals. Now let's see this one. So I'm done with the first part. Second part. Now h is coming to 0, but from values to the left of 0. So that implies that 6 plus h, if it's 6 plus a negative, that's to the left of 6. So I'm coming from over here. And the difficulty with this one is that we have to see that as this value of h gets closer and closer to 0, this entire value of f of 6 plus h gets closer and closer to 3. Minus f of 6, I know f of 6 is just 1, and I can fill that in. So this is the limit as h goes to 0 from the left over h of 2 over h, limit as h goes to 0. And here in this case, because this value over here, right, this value is just 1, right, you could see, look, in this top one, for example, as I get closer and closer to 6 from this side, f of 6 plus h is tending towards 0. This value is getting closer and closer to what as I get closer and closer? 1, and then the top and bottom are both getting closer and closer to 0, so you have to do that analysis. But in the bottom, right, you see in the top, both the top and the bottom are getting closer and closer to 0. F of 6 plus h, as I go over here, I'm getting closer and closer to 1. And then f of 6 is 1. So I just need to see that this is going to be the slope of this tangent line. But in this top part, I got to piece out this limit. And I got to see that this piece here is tending towards a different value than this part here. Or this value here is just 1. F of 6 is 1. That's nothing to do with the limit. That's just 1. Then this h value, right, is going towards 0, which is changing this value, f of 6 plus h, to getting closer and closer to 3. So the top part is tending towards 2, and the bottom part is tending towards 0. And if the top part tends towards a fixed positive or negative value, not 0, and the bottom part tends towards 0, this limit does not exist. And then, now since the left-hand limit doesn't equal the right-hand limit, you have that the limit as the whole does not exist. And we have to see how it is that f of 6 is 1. So this just becomes 1 right here. And then this is not tending towards 1. So this top part is not tending towards 0. This part here is tending towards 3. And since this top part is not tending towards 0, it's tending towards 2, I have that the bottom part is tending towards 0. So this limit, again, does not exist. The left-hand limit does not equal the right-hand limit. The limit as a whole does not exist for the third part. The first part, we should see that the top is tending towards 0 and the bottom part is tending towards 0. And it is going to be just the slope of this tangent line.